Alright, here's going to be a few examples with the complex numbers, adding, subtracting, multiplying, and dividing. So basically, if you see something like 9 minus 2i minus 3 plus 2i, something like that, we're just going to treat the I almost like it's a variable in this case. And then first off, of course, we're going to make sure we distribute the subtraction to both terms. So we'll have 9 minus 2i and then minus 3 and minus 2i, and then it's just a matter of combining the like terms. The real parts, the 9 minus 3 would be 6, and then negative 2i minus 2 more I would be minus 4i. Okay, and that's going to be your final answer. And again, just as a recap, a complex number is just something that looks like a plus bi, where a and b are just real numbers. So we see that our answer is in that form, and we just pretty much combine like terms. Okay, if we want to multiply complex numbers, we'll see an example there as well. What if we wanted to do something like 1 plus 4i times 5 minus 2i? Okay, so there's no plus or minus in between the terms here. It's just a multiplication. So it is going to be just like a FOIL problem, basically, just like multiplying, distributing binomials. So 1 times 5 is 5. 1 times the negative 2i is minus 2i. And then we move on and distribute the 4i to both, so plus 20i. And then 4i times minus 2i is going to be a minus 8i squared. Okay, and then similarly we can combine some like terms just like we did with the addition problem. So we have a 5, the minus 2i plus 20i would be plus 18i, and we have this minus I squared. And that would be fine to leave if I were a variable, if it was just x or something. But the difference here is that, if you recall, I, when we first started doing this stuff, was defined to equal the square root of negative 1. So if you were to square that, that means you're squaring a square root, and it just becomes negative 1. So we need to take the negative 1 and substitute it in for I squared. I squared always equals negative 1. And really what's going to happen then is the original minus 8i squared becomes minus 8 times negative 1 actually just becomes plus 8. And now we can combine the 5 and the 8 to get like terms. 13 plus 18i. There's your final answer. So always replace I squared with negative 1 when you're simplifying these things. Okay, and then the last thing we need to cover is division. So to an example, something like a division problem would look like negative 2 plus 5i, and we want to divide by 3 minus 4i. Okay, so the deal here, it's really, it's not going to feel like you're doing division. We're really just simplifying. And the thing is, we cannot leave any imaginary terms in the denominator. So we need to figure out a way to simplify this thing to get rid of the i's in the denominator, okay? And the trick is this, okay? You're going to multiply top and bottom of this by what's called the conjugate of the denominator. So the conjugate just means the opposite sign. So again, I'm only worrying about the denominator. Its original denominator is 3 minus 4i, so we're going to multiply by 3 plus 4i. Okay, whatever it is originally, we just do the opposite. Okay, so to keep this going, we're just going to end up actually doing two FOIL problems, basically. We have a numerator and a denominator, and if we just multiply those all out and clean it up, we should get an answer here. So we have a negative 6, negative 2 times 4i is minus 8i, the positive 5i times 3 is a positive 15i, and 5i times 4i is a positive 20i squared. Okay, and again, we know I squared is negative 1. We'll simplify that in a minute. And then we FOIL out and distribute on the bottom. So the denominator, 3 times 3 is 9. 3 times the positive 4i is going to be a plus 12i. The negative 4i times 3 is a negative 12i. And the negative 4i times the positive 4i is going to be a negative 16i squared. Okay, and then we just start to simplify a little bit, combine some terms if possible. I know these are like terms here. So negative 6, if it's negative 8i and we add 15i, that's going to be a positive 7i. Okay. Also remember, I squared equals negative 1. So this is really plus 20 times negative 1, so it's really a minus 20. Okay, and in the denominator, the reason why we chose to multiply by the conjugate, using 3 plus 4i, is so that all these i's would cancel each other out. And then I squared, of course, we talked about equals negative 1. So the denominator is really just 9 minus 16 times negative 1, which is just 9 plus 16. Okay, and notice the denominator now is just a real number. It's not imaginary at all. And the numerator, we can just combine some like terms. Okay, so we could either leave the final answer that way, or it might be better to have it in standard form where you actually split it up and you have a real part, negative 26 over 25, plus, I'm basically dividing both terms by the 25. And now it's in that standard form where it looks like some number plus b times I. Okay, and that's really it for the complex numbers. I guess one other thing we could show, let's say just a simpler case for a division problem, if it was something like 4 plus 2i over I or something like that. In that case, you could multiply by the conjugate of the denominator, which would actually be negative I. But a lot of times we just multiply by I over I. And what that does is it forces you to get in the denominator I times I is I squared, which we know ends up becoming negative 1. And then the numerator distributing becomes 4i plus 2i squared. And again, using the idea that I squared is negative 1, this ends up becoming 4i minus 2. And then you could split that up into negative 4i, and then the negative 2 over negative 1 would be a plus 1/2. Okay? Or in the other a plus bi order, this would probably be the best way to write the final answer. But again, once you get to the point where there's no imaginary terms in the denominator, that means that it is simplified. Okay?